Hello there and welcome again. So in last video we looked at how we can do object detection on top of an image. In this video we are going to look at a one step further, which is how to do an object detection on top of a video. This tutorial is divided into two parts. In first part we are going to look at how we can load a video, and in second part we are going to look at how we can apply a pre-trained YOLO model on top of that video to do object detection. So let's head on to this journey. Before we directly jump into our coding playground, let's understand the basic steps involved in object detection in a video. So first of all, we are going to load a video on which we are going to do our detection, and then we are going to load our model. Here we are using pre-trained YOLO model. You can also use your custom model in this. After that, we are going to extract each and every frame from this video, and on top of each frame we are going to apply predict, and we are going to show each and every frame with our prediction on top of it. So this is the basic structure of how we can do an object detection on top of it. So this was a very short and crisp theory of the steps involved in the prediction process. Now let's apply all of this theory using our coding. Let me show you the sample video on which we are trying to do object detection. So here is our sample video. Where are you? There you go. Now let me play it for you. So this is the sample video on which we will try to run our object detection, and we will see how successfully we are able to detect all the person, football, all the cars, basically any moving object in this video. So let's start our coding part. Let me close it, and there we go. So let's import all the libraries we need for it. So let's create a function now. What should be the name of our function? Let's name it process video, and let's first define the path of the video. Now before directly applying a object detection model on top of this video, let's just try to read this video and see whether we are able to render the video frame by frame or not. So basically we will be using opencv for this. So this is how we are going to do it. So here we are trying to read the video from the specified path. So this is how I'm going to do it. Vs is equal to cv dot video capture. Video capture is a method from opencv which will allow us to read the video from the specified path here. So this is the path. So if at all in future if you want to process any other video, you will just change the path here and it will read from here. Now let me try to create a while loop. So inside while loop we will try to process each and every frame from this video, and we will see if we can render it or not. And it's an infinite loop. Inside this we will create two variables, grabbed and frame. Idea is that frame should contain the current frame of the video, and grabbed is a boolean variable which will tell us whether we have reached the end of our video or not. There it is. So let's move to our next line, and we will try to show our frame here. So idea is that inside this frame variable we are trying to capture each and every frame from the video, and we are trying to read video from here. And let's show the frame which we have captured. Frame is nothing but an actual image, and of course video is a combination of images. So let's try to capture frame by frame. Here we will use image.show, and we will be applying wet key also to show the frame. Perfect. CV wet key 24. Perfect. Now let me run it and show you what we are processing. So let me call this function process video. Here let's run it and see. There is a small issue here. I misspelled video capture. It should be small a. Perfect. You see we are displaying here images frame by frame. If we want to delay this rendering, we can do it like that. You see the wet key here. If I delay the wet key as 50, the frame rendering will be delayed. Perfect. So this is the sample function. We are trying to just read the video here from this specified path, and we are displaying each and every frame from this video here. Now idea is that we are trying to implement an object detection model on top of this video. So, and video is a combination of all the images inside it. So ideally if we can apply our YOLO model on top of this frame, then eventually it's on top of the video. So ideally we are applying our ML model on top of a single frame, and we will trying to render it one by one. Now let's do all this theory using our coding. So let me first try to load the ML model here. So we are trying to use pre-trained YOLO model. So where is our YOLO model? It's already in our folder. We will just try to load it. Let me just comment it here. We are trying to load the model here, and here we are trying to read the video, and here we are trying to show the video frames. Now since here we have loaded the model inside our model variable, what we will do, if you remember from the last video, we will use this model to apply prediction on top of our video. And if you remember the theory as well, any sort of object detection will contain basically 3 steps. We load the model, then we load the images, and we do predict on top of our image using the ML model which we have loaded. So here is our ML model which is loaded, and this is our frame which contains the images. So let's try to do predict on top of this frame using our ML model. So inside the result, all the prediction data will be stored on top of this frame. Now let's try to decipher this result. So ideally this result should contain all our predictions on top of this frame, and this frame is grabbed from our video frame which is supplied here, this video path. So let's try to decipher it. Now let me copy some code to save our time, and there we go. So inside results we have created a for each loop, and inside for each loop we are trying to access all the box details. Box details here are nothing but all the bounding boxes details, x and xy coordinates, which define a bounding box around a detected object. We are trying to convert them into two lists because all by default they are in form of tensor, and tensor is not very reusable if you want to create a bounding box on top of an image. That's why we have converted into two lists, and we are just trying to print the data here. Now let me run it and see whether we are able to detect something or not. Perfect, at least we are able to detect something. So it's printing something. So if you want to understand it, this is the class ID. So this represents what we are detecting on a particular image, and this is the confidence score, and this is the XY coordinate of the bounding box which we are going to draw. So we have all the data, or basically all the predicted data on the top of a particular frame, and all the details to draw a bounding box. Now let's create an opencv function which will draw a bounding box on a supplied coordinates. Let me first pause it. Let's create the function. What should be the name of our function? Let's name it drawbox, and input should be our data which will contain all xy coordinate, and let's supply image as well on which we will draw our bounding box, and there we go. So let me copy some code to make our life easy. Perfect. So from data we are deciphering x1 y1 coordinate, x2 y2 coordinate, confidence of the detected object, and the ID of that object. ID basically represents what class we are trying to detect. So every class here in a COCOA dataset has been designated to ID. Using that ID we will decipher what class it is exactly. So here is our ID, and this is using CV function. We are trying to draw a rectangle on top of our image, and we are returning the same image here. So let's call this function from here, and input should be frame. Now let's run and see whether we are able to draw bounding box successfully or not. Perfect, we are able to detect each and every object inside this. Now let's try to put label on top of each box to print the exact name of our detected class on top of our bounding box. We'll be using this names dictionary inside our results. So let me just print it and show you what inside this dictionary contains. Let's run it and see. So here is our result. So this is the dictionary. This contains 0 for person, 1 for bicycle. Basically all the elements inside our COCOA class has assigned a ID. 1 ID is for bicycle, 2 ID is for car, and 3 is for motorcycle, 4 is for airplane. This is how each and every element corresponds to a corresponding ID. and using this ID we can decipher what exactly our predicted class name. So let's just go inside our bounding box data and let's just try to print detected class. So this is how we are going to do it. Print. If you'll see from our data, you will see at this point we are printing the ID of our class. So it is at location 1, 0, 1, 2, 3, 4 and 5. So if I will go inside data eventually is a list. So inside list we will go at 5th location, and inside this 5th location, so let me make it more easy, ID is equal to data and 5, and using this ID let's just save all the detection inside our detection class. So detection class is nothing but a list which I have declared here. Let me uncomment it. So detection classes will contain all the dictionary which is inside this results, and from that we are going to decipher our class name. So our detected class, and here is our ID. So let's just run and see which is the detected class. You see, for each frame we are printing, this is a class. Here we have detected bench, here we have detected person, here we have detected person again. Is that whenever we are detecting a bounding box, let's print exact label on top of this bounding box so that it's easy to identify that how accurately we are identifying objects in this video or in this frame basically. Now since we have detected class name inside this ID, so let me supply this ID inside this function. This will make our life a lot easy. ID should be here. Let me comment this print statement. Perfect. So inside this drawbox function we are passing class name as well. Let me change the signature of this function. Drawbox, here we are accepting name as well, and using cv.putText function we will try to put the text on top of our image. So here is the image on which we are trying to put the text, and this is the coordinate. So coordinate is directly taken from the p1 here. So p1 is nothing but just a combination of x1 and y1, and this is the font, this is the color of the font, this is the size of our font. Let's just run and see. That's too much of theory. Let's run and see it's in action. Perfect. You see, this is our bounding box. Here is our detected class. This is person, this is a sports ball, this is person again. Perfect. Our YOLO pre-trained model is working perfectly in this video. So let's try this with another video. So we are trying to detect the cars on this highway here. Let's see how our ML model behaves to this video. Let me cross it, and then let me first copy the path of this video. See, our life is easy. We just have to change this path here, and that's it. All set. Let's just run it. Perfect. Car. I don't know why this is coming as a truck here. Looks like YOLO need more training. Let's do one more thing. Let's try to detect only a particular class inside a video. So this is how we are going to do it. First, let me go inside our frame model.predict. So inside predict, if we want to detect only a particular class, we will do it like that. You must have seen this in earlier video also. If you want to detect only a particular class, suppose I want to detect only person, how do I know what is the ID of person? We know because of our ID here. So you see 0 is for person, so we want to detect only person, so we will supply only person here. Let's not do with person, let's detect only football. We are going to detect only football here, and let's change this video to our earlier video. Let's run it. Amazing, we are able to detect a sports ball on a moving video frame. Now let me increase the frame speed a bit, it's too slow right now. So to increase the frame speed, if you remember here we have given a weight key of 500. Let's decrease it to 24, and let me run it again. Perfect, we are able to detect a sports ball in a moving frame. Amazing, isn't it? So this is the most easy way how you can detect object in a video. So this is it for the current video. In next video, we are going to look at how we can count the number of objects in a video. We are going to see how we can apply deep sort to count the number of moving vehicles in a video. So see you in next video, guys.